Hello dear students, in this video we are going to speak about action potential and the resting potential. So mainly we are going to speak about the transmission of nerve impulse throughout the axon. So the axon is going to receive the impulse from the dendrite, is going to go to the cell body, then is going to be transmitted through the axon until it reaches the synaptic knobs. So how does this happen? We need to see how the neuron is before any stimuli. Before any stimuli, if you look at the state of the neuron, we call it resting potential. So resting potential, if you look at the neuron, the outside of the neuron is positive. So it is positively charged. And inside of the neuron is negatively charged. And why is that? So outside is positively charged and inside is negatively charged. But why? If you look here inside of the neuron, you'll find that we have high concentration of sodium ions. So here outside of the neuron we have high concentration of sodium ions. Here you'll find high concentration of sodium ions. Inside of the neuron you'll find large molecules which are negatively charged of protein. So here we have protein which are negatively charged. We have some potassium which are positive. We have some sodium, but mainly which ions are more concentrated? Is it the sodium, potassium, or the protein? We will find that the protein dominates the charge here because they are a lot. The concentration of potassium is too little, will not make it that much to be positive inside. So outside the neuron is positively charged because of high concentration of sodium. Inside of the neuron is negatively charged because of high concentration of protein. This state we call it resting state. This is resting potential. So what is the difference potential here inside of the neuron? When we speak about difference potential, we are speaking about the charge inside of the neuron. If we measure it, it will be negative 70 millivolts. So at resting potential, the state is negative 70 millivolts. So this was the first stage. The first stage is resting potential. Your neuron is at this resting potential. If you do not have any stimuli, if you do not see anything, if you do not touch anything, if you do not feel anything, now the neuron is at resting potential. What is the difference potential here? Is negative 70 millivolt. So this is stage one. What happens if you touch something, if you feel something, if you see something, if you hear something? Now the difference potential is going to change because now sodium ions, this channel will open, sodium channel will open, sodium will diffuse into the neuron. So here we have sodium and sodium will diffuse into the neuron. This we will call it action potential will start. So the first stage of action potential is when this happens. How does it happen? Well, this happens when sodium diffuses into the neuron. So if you look here, sodium channels before any stimuli are closed, they will open, then now sodium can diffuse into, so sodium ions can diffuse into the neuron. Now inside of the neuron will be positively charged, outside will be negative. So we had here sodium ions, they will diffuse into the neuron. Now it will be positive inside because sodium concentration will dominate the charge, so it will make it positive inside. So positive what? It will be positive 30 millivolts. It will go to positive 30 millivolt. Why it changes to positive 30 millivolt? Because sodium will diffuse into the neuron, and this state we call it depolarization. So depolarization, when sodium diffuses into the neuron, this state we call it depolarization. What causes depolarization is the diffusion of sodium into the neuron. What happens when a stimuli comes to the receptor is going to trigger action potential. When sodium channel opens, sodium diffuse into the neuron. Now it is going to increase the difference potential inside of the neuron, is going to make it positive 30. Now this charge to continue to other places. For example, now here it will happen here. Now it will happen. Look, it happened in this place. Now it needs to happen in this place. But this one needs to go back to its state before as it was. So this we will call it repolarization. So what is repolarization? Let's see, repolarization. Repolarization, when that potassium, now inside of the neuron, it has potassium. Sodium just diffused in. Now here inside of the neuron we have sodium. And we also have potassium already inside of the neuron. So to make it negative, now the potassium will diffuse out of the neuron. So sodium entered, it made it positive inside of the neuron. Now potassium will take its place outside. So potassium, as you can see here, potassium will diffuse out of the neuron. So from here, potassium is going to diffuse out of the neuron to make it positive again in that place, so sodium can enter to the next place. This will cause like a wave of depolarization and repolarization, depolarization, repolarization, depolarization, repolarization along out the axon, and this is what we call action potential. So action potential is a wave of depolarization and repolarization which happens along the axon. This will trigger action potential and will allow the impulse to travel throughout the axon of the neuron. Now this happened. The process has done. We are done, and the neuron has conducted the impulse from the beginning of the neuron until its end. Now it needs to go back to its potential of resting potential. So it needs to go back as it was. Now look here, it is positive, but potassium is out, made it positive. Before it was sodium out, which made it positive. Now we need to rearrange the ions back as they were before this action potential start. So we need sodium to go out of the neuron, and we need potassium to get into the neuron. What's going to do this job? To make it back to the polarization state, which is outside positive and inside negative. What will make it? We have this pump. We call it sodium potassium pump. Why we call it sodium potassium pump? Because it will push sodium out. As you can see here, it will get 3 ions of sodium and push them out, and it will get 2 ions of potassium and push them in. So sodium potassium pump will push out sodium out of the neuron to their resting potential as they were, and it will restore sodium into the neuron, inside of the neuron. And this process, as you can see, this pump will use ATP, adenosine triphosphate, which is energy, is going to use it and change ATP to ADP, which is adenosine diphosphate. Now we had adenosine triphosphate will change to adenosine diphosphate, and this is the energy which will make that pump work. So this pump will work to restore the ions. It will restore sodium out and potassium in, so it will go back to its state of resting potential again to make it negative 70 millivolt. The charge, the difference potential will be back as it was, negative 70 millivolt. Now if we look at this one as a summary here, the first state we call it resting potential. Resting potential, outside is positive, inside is negative, inside of the neuron is negative. Outside is positive because it have high concentration of sodium. Inside is negative because it has high concentration of protein. Now this state we call it polarization. Why we call it polarization? Because just like a battery of a car, if you look at the battery of the car, it has the positive and the negative terminal. Here are positive and negative. This we call it poles. We have the positive terminal and the negative terminal. This we call it polarization. The neuron is just like a battery at this state. Outside is positive, inside is negative. So we have two poles, positive, negative. Here the potassium sodium pump works. The sodium channel are closed. So sodium channel close, potassium channel close. Sodium potassium pump works. Let's go to the action potential. Action potential it has two stages. The first one, depolarization, and the second is repolarization. In depolarization, the sodium channels will open and sodium will diffuse into the neuron. It will make it positive inside, negative outside. This is depolarization. This will increase the charge to positive 30 millivolt. It was negative 70 millivolt at the state resting potential. It will increase to positive 30 millivolt. Then we'll go to repolarization. Repolarization, here we want to make outside positive, so potassium will go. Why? Because sodium just entered, so it cannot go right away. It needs time. So instead, potassium will go out, so it will make outside the neuron positive, and inside, because it will get out many ions, positive ions, so the protein concentration will be back again more. So the negative ions of protein will dominate the charge inside. It will be negative, outside will be positive. Now once this is done, which is depolarization and repolarization, which will be like a wave of positive and negative charges, now we need to make the charge back as it was. So the neuron is going to go to the resting state. What will happen? The sodium potassium pump will get out sodium and will push potassium in to restore it as it was before anything happens. If you look here, resting potential and repolarization, they have similar charge, but be careful. Here it is positive because of sodium. In repolarization, it is positive because of potassium. Will make this charge positive again. It will increase the positive ions. Here it is positive in resting potential because high concentration of sodium, but when sodium diffuse in, now potassium will go out to increase the positive charge outside the neuron to make it positive again. After this happened and finished, now the neuron is going to restore its original state by pushing out sodium out and potassium into the neuron by the help of the sodium potassium pump. To summarize, to make a summary for all what happened, let's look at this graph. It is very important. At resting potential, you're not feeling anything, you're not hearing anything, you're not touching anything. We can say it is at resting potential, which is negative 70 millivolt. Now, if the stimuli is strong enough to reach negative 55, if it is strong enough to reach this number, negative 55, between negative 50 to negative 55, now this we call it threshold potential. Threshold potential, if the action potential is strong enough, if the stimuli is strong enough to go above this, now it will fire action potential. So negative 70 is resting potential, negative 55 we call it threshold potential. Now the sodium ion, here we can say sodium will cause the charge to go to positive 30. Now this is the depolarization. So if you look here, the sodium channel closed, the potassium channel closed, but the sodium potassium pump works. If we look at 2, depolarization, what will cause it? It will cause a sodium. Sodium gated channels will open. Now, if you look, sodium channel open, sodium will diffuse into the neuron. It will increase the difference potential from negative 70 to positive 30 here. Now, it will cause this depolarization. The neuron needs to go back outside positive, and inside needs to go back to a negative state. This is, we call it repolarization. What happens? If you look, the potassium channel will open, potassium will go out, and what is responsible of repolarization is the potassium ions. After all of this happened, now the neuron needs to go to resting potential again. Look here, it needs to go to resting potential to negative 70 millivolt. So what's going to cause it to go back to the same state is resting potential, the sodium potassium pump. By using energy, ATP is going to make it back to the resting potential. And this is how action potential happens and how the nerve impulse travels from one neuron to another. I hope this is clear. Until next video, ciao.